how to solve anything in mathematics. And there will be more videos on this in these sets of videos specifically for how to solve anything in mathematics. Mathematics is actually really easy once you know all the stuff. Just algorithms, logarithms. You gotta know what they mean, what they really mean, not from some fucking stupid book that doesn't actually tell you. And you can solve anything in mathematics by using all of the different steps of solving, right? It doesn't matter if it's trigonometry, calculus, algebra. It doesn't matter what kind of part of mathematics it is in that. There are all these different ways of actually solving stuff, right? Solving things, right? But usually if you use like the PEMDAS, you use PEMDAS, BODMAS, or whatever, it's different in different parts of the world. Parentheses, exponents, multiplication, division, addition, and subtraction, right? I explained that in one of the other videos. It doesn't matter how complicated it is. It doesn't matter if it's a mathematical expression. It doesn't matter if it's a quote-unquote formula, or if it's an equation. Technically, an equation is anything with an equal sign, technically. And you just solve it. You solve it part by part. It doesn't matter how complicated it is. You solve it little by little, part by part. Okay, you break it down to the whole numbers or the decimal numbers, right? So remember, like 99. It was square root 2 over 99 squared, right? So all you do on Ramanujan's like algorithm there, right? Technically it's an algorithm. You do square root 2 and you'll end up with like a decimal number, right? Because that decimal number times itself equals a whole number 2. And you're only multiplying it by itself once to get the square, right? And then there's like cubes and stuff like that, but it's not a cube, it's a square. So you end up with a decimal number, and it's above a fraction bar, which is on the bottom. It's a 99 squared, right? So that's 99 times 99, which is 9801, right? So then you divide it. You divide 9801 by that but you divide 9801 into that decimal number. It pops out with another number, okay? And then you reverse divide. You reverse divide it. So you divide it both ways, top to bottom, bottom to top, right? You're going to end up with two completely different numbers. And you'll find, actually, when you do this, you're going to find like Euler's number all over the place. And you're going to find like all kinds of really cool like patterns and stuff, But anyway, that's not how to discover a pattern. And I'm not going to show anybody how to discover patterns, because if I did that, then, whatever, everybody would be doing it. But you do that, and then you end up with like two completely different strings of numbers. And then you do like the rest of it, right? So like the exclamation means like product or not in mathematics, whatever's like left over, kind of, So like 4k, and remember, like on the summation, right? It goes on infinitely. If it has an infinite symbol on the top of the sigma symbol, that means it goes on forever. When it starts at 0, and then if above the sigma there's only like a 5, it's only the variable is only going to go to 5. So if it was like 5 sigma k equals 0, then you'd start at 0, and then you'd do it again, 1, 2, 3, 4, only to 5, and then you'd stop, right? So you don't even mess with that. You just substitute all the rest of the stuff in that. You substitute the variable k for 0, and then you multiply 0 against whatever, or it'd be like 1103 plus 0 over fraction bar, and then like the next like part of it, and you just solve it. You break it all down into the decimals and the whole numbers. Now once it's done, you multiply it. Once it's done, you multiply it, because that's what's indicated when it's right next to each other like that in an expression statement or whatever. It means that you multiply it. So you multiply these numbers against these numbers, and then bam, you got the next decimal place of pi. That's how you get it, and it goes on forever. It goes on infinitely. So they have computers that crunch this all day long to get like millions and millions and millions and billions and trillions of decimal places of pi, and they've only gotten like so far, because it goes like, million, billion, trillion, quadrillion, and then like in the Greek, like the Greek naming